In this problem, we're going to revisit something we did last time using only the conservation of momentum, and we're going to add energy into this equation to see how we can put it all together and find out more information from less. We have a proton that is traveling to the right at 2.0 times 10 to the 7 meters per second. The mass of the proton is going to be 1 atomic mass unit. It's going to run into a carbon that has a mass of 12 atomic mass units in a perfectly elastic collision when it starts at rest. So before the collision, it looks like this, and after the collision, since the proton is much smaller, it should be going to the left, and the carbon should be going to the right. So we're going to call this V carbon, which is unknown, and V proton, which is unknown. And the carbon has mass of 12 AMU still. So in our momentum only problem, we were given the velocity of the proton and asked to find the carbon. Now we don't know either one, but we have new equations. So the conservation of momentum is the sum of all the momenta before is equal to the sum of all the momenta after, and the sum of all the energies before is the sum of all the energies after. So for each guy, before and after, we need to find the momentum and the energy. So a momentum is mass times velocity, and an energy is 1/2 mass times velocity squared. So for the proton, which we're going to label P, we have V initial of 2 times 10 to the 7 meters per second. So that means our momentum of the proton initial is equal to 1 AMU times 2 times 10 to the 7 meters per second. So 2 times 10 to the 7 AMU meters per second. That means the energy of the proton initial is 1/2 mv initial squared. So that is 1/2 times 1 AMU times 2 times 10 to the 7 meters per second squared. So this is 2 times 10 to the 14 AMU meters squared per second squared. So we have the initial momentum of the proton and the initial energy of the proton. The carbon, which we'll label C, is pretty easy because it's not moving. It has a velocity initial of 0. So P carbon initial is equal to mv initial, which is 0. And E carbon initial is 1/2 mv initial squared, which is 0. Now that we have both of these, we can find the total initial momentum. P initial is equal to P proton initial plus P carbon initial, which is 2 times 10 to the 7 AMU meters per second plus 0. Which is just 2 times 10 to the 7. The total initial energy is E proton initial plus E carbon initial. This is just 2 times 10 to the 14 AMU meters squared per second squared plus 0. AMU meters per second squared meters squared per second squared. So we have both the initial momentum and the initial energy. So now we just need to write expressions for the final momentum and final energy. So we'll start with the proton again. Its final velocity is v proton. And that's an unknown and something we want to solve for. P proton final is equal to mv final. And that's 1 AMU times Vp. So that's just velocity of the proton times 1. The energy, energy proton final, let's make that look a little nicer. Proton final is equal to 1/2 mb final squared, which is 1/2 times 1 times Vp squared. 1/2 Vp squared. The carbon has a final velocity that we call Vc, which is unknown. P carbon final, mv carbon. So this is 12 times Vc, because the mass of the carbon is 12 times the mass of the proton. E carbon final is equal to 1/2 mv final squared, which is 1/2 times 12 times Vf squared, 6 Vf squared. Now that we have both of these, we can do P final is equal to P carbon final plus P proton final. That's Vp plus 12 Vc. And E final is equal to 1/2 Vp squared plus 6 Vf squared. So 2 equations and 2 unknowns, because now we can use conservation of energy. So we have these guys here, and conservation of momentum. Pi equals Pf. Pi was 2 times 10 to the 7, and that is equal to Vp plus 12 Vc. And Ei equals Ef, that is 2 times 10 to the 14 equals 1/2 Vp squared plus 6 Vf squared. So these are our 2 equations from conservation laws. And now we just need to use algebra to solve. So what I want to do is take this guy and solve it for Vp. Vp is equal to 2 times 10 to the 7 minus 12 Vc. And take it and plug it in for here. So 2 times 10 to the 14 is equal to 1/2 2 times 10 to the 7 minus 12 Vc squared plus 6. I have a typo here. This is Vc plus 6 Vc squared. 2 times 10 to the 14 equals 1/2. 2 times 10 to the 7th squared is 4 times 10 to the 14th. Plus 12 times 12 is 144 Vc squared. And then 12 times 2 is times 10 to the 7th is minus 4.8 times 10 to the 7. plus 6 VC squared. So I just FOILed that guy out. And now I'm going to do the division. 2 times 10 to the 14th plus 144 divided by 2. 72 VC squared minus 2.4 times 10 to the 7th plus 6 VC squared. So this guy is going to cancel with this guy. 0 is equal to 72 VC squared plus 6 is 78 VC squared. And this should have a VC in it. Minus 2.4 times 10 to the 7th VC. 78 VC squared is equal to 2.4 times 10 to the 7 VC. 1 will cancel because VC is not going to be 0. 78 VC is equal to 2.4 times 10 to the 7. Divide both sides by 78. VC is equal to 2.4 times 10 to the 7 divided by 78, which is 3.08 times 10 to the 5 meters per second. And then we just have to go back to our previous equation. Let's use this one. 2 times 10 to the 7 is equal to VP plus 12 VC. 2 times 10 to the 7, and just take this and plug it in for VC. VP plus 12 times 3.08 times 10 to the 5. This times 12. 3.08 E5 times 12. 2 times 10 to the 7 equals VP plus 3.696 times 10 to the 3.456. So minus 3.696. Oops. Gives us 2E7 minus 3.696E6. That gives us the velocity of the proton is 1.6 times 10 to the 7 meters per second. And it's going the other way, so we're going to include a minus sign.